Next we move to problem number 22. It says given the following data, so compound is LIF, delta H naught F is given in kilojoule per mole is minus 617, ionization energy value is also given 520, value of EA is also given minus 328 kilojoule per mole, and sublimation, heat of sublimation is also given 161 kilojoule per mole. For LICL the corresponding values are minus 4.08, minus 408, 520, minus 349 and 161. So, bond dissociation energy of F2 and Cl2 are minus 79 kilojoule per mole and 122 kilojoule per mole. Calculate the difference in lattice energy between LIF and LICL. So, this is based on Born-Haber cycle. So, according to Born-Haber, we write delta H F naught is delta H sublimation plus delta H dissociation plus IE plus EA plus U, right. For LIF, delta H F naught is minus 617 kilojoule mole inverse, IE of LIF is 520 kilojoule, IE of LIF is given is 520 kilojoule mole inverse, and then value of delta H dissociation of F2 is 79 kilojoule mole inverse, EA of fluorine is minus 328 kilojoule per mole, delta H sublimation for Li is 161 kilojoule per mole. Here we can write IE of Li, this is 520. Okay, now we can calculate U. Okay, so U of, if we substitute all these values, we get U of LIF is delta HF naught minus delta H sub minus delta H this minus IE minus EA. So, we get the, we put the values. So, minus 617 minus 161 minus 79 minus 520 plus 328. This is in kilojoule per mole unit. So, if we calculate this, we get the value minus 10,1049 kilojoule mole inverse. This is for LIF. For LICL, delta H F naught is minus 408 kilojoule per mole, IE of Li is 520 kilojoule per mole, EA of Cl is given as minus 349 kilojoule per mole, delta H sub is 161 kilojoule per mole, and delta H dissociation of Cl2 is also given is 122 kilojoule mole inverse. So, if we calculate now ULICL is minus 408 minus 161 minus 122 minus 520 plus 349. So, we get minus 862 kilojoule per mole. So, we need to calculate the difference, okay, lattice energy difference. So, lattice energy of LIF, this is lattice energy of LIF. And this is the lattice energy of LICL. So, the difference in lattice energy between LIF and LICL is ULIF minus ULICL will be minus 0.49 minus 862. So, we get minus 187 kilojoule per mole. Next, we discuss problem number 23. For CaO, sublimation of Ca is given plus 178 kilojoule per mole. Ionization energy of Ca is also given 590 kilojoule per mole. For IE1 and for IE2 it is 1145 because Ca in CaO, Ca is plus 2 charge. Okay. So, that is why there are two ionization energies are given. Bond dissociation energy of O2 is also given. O2 to 2O is 498 kilojoule per mole. Electron affinity of O is also given. So, there will be two electron affinities EA1 and EA2 because O will be minus 2 charge here. So, value of EA1 is minus 141 kilojoule per mole and value of EA2 is plus 744 kilojoule per mole. Lattice enthalpy of CaO is also given minus 3460 kilojoule per mole. We need to calculate the enthalpy of formation of CaO. So, we have to again use Born-Haber equation. Okay. So, for CaO, the Born-Haber equation will become delta H not F is delta H sub plus delta H dissociation of O2 plus IE1 plus IE2 plus EA1 plus EA2 plus U. Here delta H sub for calcium is 178 kilojoule per mole. IE1 of Ca is 590 kilojoule per mole. IE2 of Ca is 1145 kilojoule per mole. And EA1 of O2, EA1 of O is minus 141 kilojoule per mole, and EA2 of O is also given plus 744 kilojoule per mole. Okay, bond dissociation energy. So for each delta H dissociation is also given of O2, delta H dissociation of O2 is 498 kilojoule mole inverse. U is also given, okay, the lattice enthalpy of CaO is minus 3460 kilojoule per mole. Now you substitute all the values there, we get delta H not F is 178 plus 498 by 2, because we are using in CaO there is only one oxygen atom, and for O2 dissociation we get 498, value of the delta H dissociation is 498, so it has to be divided by 2 here, plus 590 plus 1145 minus 141 plus 744 plus minus 3460. So if we calculate this, we get the value of minus 695 kilojoule per mole. Therefore, the enthalpy of formation of CaO is minus 695 kilojoule mole inverse. Next we move to problem number 24. It says given delta H solvation of NaCl is plus 3.9 kilojoule per mole, delta H hydration of Na plus is minus 406 kilojoule per mole, and delta H hydration of Cl minus is minus 363 kilojoule per mole. Calculate the lattice enthalpy of NaCl. So here given delta H solvation is for NaCl is 3.9 kilojoule per mole. Delta H hydration for Na plus is minus 406 kilojoule per mole, and delta H hydration for Cl minus is minus 363 kilojoule per mole. Now consider the following equations. First equation is we have NaCl solid. From there we get Na plus gas plus Cl minus gas, right? And for that we get lattice. Second is Na plus gas goes to Na plus aqueous. This is nothing but delta H hydration of Na plus. And third is Cl minus gas to Cl minus aqueous. This is delta H hydration of Cl minus. Okay. Therefore, delta H solvation will be U lattice minus U lattice plus delta H hydration plus of Na plus delta H hydration for Cl minus. Now, delta H solvation is given, so this is 3.9 kilojoule per mole. So, minus U lattice we need to calculate. Delta H hydration is also given, hydration of Na plus is minus 406 kilojoule per mole, and delta H hydration of Cl minus is also given, minus 363 kilojoule per mole. So, we get U lattice that we need to calculate. Lattice enthalpy of NaCl is minus 3.9 minus 406 minus 363 kilojoule per moles. So, if we calculate this, we get minus 772.9 kilojoule per mole. Therefore, the lattice enthalpy of NaCl is minus 772.9 kilojoule per mole. Next, we discuss problem number 25. Born-Haber cycle of silver bromide is given. Delta H naught F of AgBr is minus 100 kilojoule per mole. Sublimation of Ag is plus 285 kilojoule per mole. Ionization of Ag plus 731 kilojoule per mole. Bond dissociation energy or bond energy of Br2 is plus 193 kilojoule per mole, and electron affinity of Br is minus 325 kilojoule per mole. We need to calculate lattice enthalpy of AgBr. This is very straightforward. So, for Born-Haber cycle, we write delta H naught F is delta H dissociation plus delta H sublimation plus IE plus EA electron affinity, ionization energy, electron affinity, and then U lattice energy. So, here given delta H naught F is minus 100 kilojoule mole inverse, delta H sublimation is 285 plus 285 kilojoule per mole, IE ionization enthalpy of Ag is 731 kilojoule per mole, EA electron affinity of Br is minus 325 kilojoule per mole. Again, the bond energy of Br2 for this we need to consider this reaction. Br2 goes to 2Br is plus 193 kilojoule per mole. Therefore, delta H dissociation will be half of 193. So, half times 193 kilojoule per mole. So we get 96.5 kilojoule per mole. So we can write from here using Born-Haber cycle, we can write minus 100 is 96.5 plus 285 plus 721 minus 325 plus u. So the value of u will be minus 100 minus 96.5 minus 285 minus 721 minus not minus plus 325 kilojoule per mole. So if we calculate this, the value of u will be minus 887 kilojoule per mole. Therefore, the lattice energy of AGBR is minus 887 kilojoule per mole. Next we move to problem number 26. The formation of MgCl2 is represented by Mg plus Cl2 gives MgCl2. So values of delta H naught F is given for MgCl2 is minus 641 kilojoule per mole. Sublimation of Mg is given plus 150 kilojoule per mole. Bond energy of Cl2 is also given plus 242 kilojoule per mole. Electron affinity of Cl2 is also given minus 349 kilojoule per mole. Lattice energy of MgCl2 minus 2526 kilojoule per mole, and second ionization enthalpy of Mg is given 1450 plus 1450 kilojoule per mole. We have to calculate the first ionization enthalpy of Mg, okay, because Mg is 2 plus here. Okay. So again we will use the Born-Haber cycle. Okay. So therefore here the process involving the processes involving the formation of MgCl2 are following. First is Mg solid plus Cl2 gas gives MgCl2 solid. Here this is nothing but delta H naught F, okay, or delta H naught formation of enthalpy of formation of MgCl2. The processes are Mg solid goes to first, this is using Born-Haber cycle, okay, so it goes to Mg gas. So this is nothing but delta H sublimation. Next is Mg gas goes to Mg plus gas. This is IE1, right? Ionization enthalpy 1, because Mg in MgCl2 Mg is plus 2, so this is ionization enthalpy 1 for the process Mg goes to Mg plus. So Mg gas plus 2 goes to Mg plus 2 plus, this is ionization enthalpy, second ionization enthalpy IE2, okay, that is given here, but we need to, this one we need to calculate. Next is Cl2 gas goes to 2Cl gas, this is nothing but delta H dissociation we get, okay, and then 2Cl gas to 2Cl minus, we get, this is your electron affinity Ea, okay, this is again gas, okay, and Mg 2 plus plus 2Cl minus gives MgCl2 solid. This is lattice energy. Okay. This is lattice energy of MgCl2. Now we substitute all these values. Okay, so we know from Born-Haber cycle, we know delta H not F is delta H dissociation plus delta H sublimation plus IE1 plus IE2 plus 2EA plus U. So, delta H not F we know, or first we need to calculate IE1. Okay, so, IE1 is delta H not F minus delta H dissociation minus delta H sublimation minus IE2 minus 2EA minus U. Now we substitute all the values. So, we can write IE1 is delta HF naught is given minus 641, delta H dissociation is also given, right. So, delta H dissociation, delta H dissociation is also given. Okay, dissociation is your minus plus 242, so 242 here. Delta H sublimation is also given 150. Okay, IE2 is also given minus 1450 minus 2 times EA, value of EA is also given 349. So, times minus 349 and minus U is 1.1450. So, if we calculate this, we get I1 is 741 kilojoule mole inverse. Therefore, the first ionization enthalpy of Mg is 741 kilojoule mole inverse.